So interference is when two waves collide with each other and overlap. So it's when two waves meet and overlap on the same medium. So when two waves meet in a medium, when two waves meet in a medium and overlap. I want to get that off. So it's when they meet in the middle and overlap on a medium. Okay. So whatever they're traveling through, they meet in the middle. What are the two types of interference? The two types are constructive and destructive. In general, the way to think about them is constructive, add together, and destructive, subtract. So, constructive add, destructive subtract. Subtract from each other. Okay, so here's the first example, is constructive. Okay, so I've got a wave going to the right. I've got a wave going to the left. So we'll call this wave A going right. We'll call this wave B going left. Okay, they go a little further. Still B going left. Still A going right. So what happens when they meet? What happens in the middle? Well, conservation of energy. We did this in the last unit. So energy cannot be created or destroyed, but it can change forms. Waves are energy. So you cannot destroy a wave unless you do work on it or something like that. So when the waves meet in the middle, the total energy has to be the same. So what should the value be when the waves meet in the middle? Right. So it's 1 for A, it's 1 for B, which means the value for both should be 2. And you should have seen that in the Slinky lab. When you did constructive interference, you saw kind of a wave going one way, wave going the other, and when they met, they kind of made some like super wave. And that super wave is what kind of went larger than you would have expected. Okay? So there's your wave. What's really happening is you have A and B adding together, but when they add together, they make some super mondo wave. And that's because the conservation of energy has to be true. Okay? And then, afterwards, they pass through and they keep minding their own business. Okay, so B passes through A. And the reason I know they pass through each other and don't bounce off is because of when you did the lab and you sent a wave one direction and it hit, it flipped and came back. These are not flipping. So that's how I know they're not colliding with each other and bouncing off. They're passing through each other and adding their motion together, adding their energy together. So that's what's going on. So that's constructive interference.
How'd you draw it?
How did I draw it? Oh, okay. Sorry. All right, so there's A, there's B. All right. let's look at destructive. Notice that destructive, the only difference is we flipped B upside down. So B is -1 going left. A is +1 going right. Okay? Still A going right, positive. Still B going left, negative. What happens in the middle? Again, energy can't disappear. So the total energy has to stay the same. We got energy of A to be +1, energy of B to be -1. So when they meet in the middle, the value is? 0. The value is 0 when they meet in the middle. That means it's going to look like this. It's going to be a flat line. But really what's going on is we've got B down here at -1 going left, and we've got A up here going that way. And then they'll pass through each other just like the other one did. Oh, I drew B wrong way. Like that. So, constructive, they add together. Destructive, they subtract out. Let me mention this. Just because it's destructive doesn't mean it always cancels out perfect. If the positive is +5 and the negative is -3, then they'll cancel out to +2. They'll subtract to +2, not to 0. They only go to 0 if they're the exact same value, positive and negative. Okay? But that's how destructive works. So let's jump to the back. I'm going to look at the first one. I'm going to turn you guys loose on the second one. All right, what if we add these two waves together? What if we add wave 2 and wave 1? So I'm looking at -3, -1, +1, +3. And if you're wondering, why am I looking at those values? I'm looking at those values because that's where we're at the maximum amplitude, which is what I care about. I care about the amplitude points. I don't care about in between. Okay, I care about the amplitudes. So at 3, what should the value be? Well, this one's got an energy of 3. This one's got an energy of 1, which means I should be at 4. Okay, this one's -3. This one's -1. That should be -4. Okay. And then the wave is the same from there, back to +4. Back to -4. Which means you're going to end up with something like this. Something like that. So, is this constructive or destructive? Constructive. This is constructive. Yes. Because they're adding together to make a larger wave. They're not subtracting out to make it smaller. Yep. Okay. You are going to see a question like this or like this on the test. Just straight up tell you, you're going to see one like this, where I'm going to give you a wave or I'm going to give you wave pulses, and you have to draw for me what it will look like. Okay? You're going to see. It's going to happen. Okay? It'll either be multiple choice and you'll have to pick the correct one that it looks like, or you'll have to draw it yourself. But you're going to see one. And it'll either look like this front page or it'll look like this back page. Okay? So what I want you guys to do is I want you to do the next two, situation B and situation C. So look at what are the values. What are the values for wave 1? What are the values for wave 2? By the way, wave 1 is the same for all three. So it only matters about wave 2. Okay? So anyway, that's what you want to look for. Mason, question? I'll come look at it. Okay? So that's what you do on this one. So go ahead and finish this. Then go ahead and finish practice 3. Whatever I did with it. There we go. Then finish practice 3. So finish the waves. Finish practice 3. And then do whatever needs to get done. Get the labs done so you can turn in the slinkies. Again, lab A, staple your white papers, put it on the second table from the right. Okay?